topic is maintenance and preservation of microorganisms. Once a microorganism has been isolated and grown in pure culture, it becomes necessary to maintain the viability and purity of the microorganism by keeping the pure culture free from contamination. Similarly, a microbiology laboratory has to maintain quality control stocks obtained from the ATCC or commercial vendors. ATCC is nothing but American culture stock. QC strains are required for the testing of culture media, kits and reagents. It's the overview of preservation and maintenance of microorganism. Normally in laboratories, the pure cultures are transferred periodically onto or into fresh medium, that is subculturing, to allow continuous growth and viability of microorganisms. The transfer is always subject to aseptic conditions to avoid contamination. Since repeated subculturing is time consuming, it becomes difficult to maintain a large number of pure cultures successfully for a long time. In addition, there is a risk of genetic changes as well as contamination. Therefore, it is now being replaced by some modern methods that do not need frequent subculturing. These methods include refrigeration, paraffin method, cryopreservation and lyophilization, otherwise called as freeze drying. In two types, short-term storage and long-term storage. In short-term storage, periodic transfer to fresh media, refrigeration, preservation in glycerol at minus 20 degrees Celsius, stab cultures and cooked meat medium. It is under anaerobic condition. Long-term storage, freezing at minus 70 degrees Celsius, cryopreservation, lyophilization is otherwise called as freeze drying, recovery of bacteria from lyophilized storage condition, paraffin method. In short-term storage, periodic transfer to fresh media. Strains can be maintained by periodically preparing a fresh culture from the previous stock. Many more common heterotrophs remain viable for several weeks or months on a medium like nutrient agar. The transfer method has the disadvantage of failing to prevent changes in the characteristics of a strain due to the development of variants and mutants. Next, refrigeration. Pure cultures can be successfully stored at 0 to 4 degrees Celsius in refrigerators or cold rooms. This method is applied for a short duration, 2 to 3 weeks for bacteria and 3 to 4 months for fungi. Molds can be stored on potato dextrose agar slants at 4 degrees Celsius for 6 months to 1 year. Next one is preservation in glycerol at minus 20 degrees Celsius. Grow a pure culture on an appropriate solid medium. When the culture is fully developed and scrap it off with a loop. Suspend small clumps of the culture in sterile neutral glycerol. Distribute in quantities of 1 to 2 ml in screw capped tubes or vials. Store at minus 20 degrees Celsius. Avoid repeated freezing and thawing. Transfer after 12 to 18 months. This is step of preservation in glycerol at minus 20 degrees Celsius. Stab cultures. These cultures at room temperature are used for non-fastidious organisms only, such as Staphylococci and Enterobacteriaceae. Prepare tubes with a deep bud of carbohydrate-free agar. Tryptic soy agar is recommended. Stab the organism into the agar. Incubate overnight at 35 degrees Celsius. Close tube with screw cap or cork. Dip cap or cork into molten paraffin wax to seal. Stored at room temperature. Transfer after 1 year. This is the agar deep. Stab culture in cysteine trypticase agar method is recommended for the preservation of Neisseria and Streptococci. Prepare tubes of cysteine trypticase agar. Stab the organism into the medium. Incubate overnight at 35 degrees Celsius. Close tube with screw cap or cork. Dip cap or cork into molten paraffin wax to seal. For Neisseria, store at 35 degrees Celsius and transfer every 2 weeks. For streptococci, store at room temperature and transfer every month. Next one is cooked meat medium. It's under anaerobic condition. Cooked meat medium is used for the preservation of anaerobic bacteria. Inoculate tubes of cooked meat medium with the isolate. Incubate overnight at 35 degrees Celsius. Close tube with screw cap or cork. Store at room temperature. Transfer every 2 months. The medium is Robertson cooked meat medium, that is RCM medium is used for this method. Long-term storage. Long-term preservation methods permit intervals of months or even years between subcultures. Isolates may be stored indefinitely if they are maintained frozen at minus 70 degrees Celsius or below. These temperatures can be achieved in an ultra-low freezer or a liquid nitrogen freezer. Liquid nitrogen freezer temperature is minus 196 degrees Celsius. Lyophilization or storage at minus 70 degrees Celsius or below is the best method for long-term preservation of bacterial culture, and general storage of isolates at minus 20 degrees Celsius is not recommended. Freezing at minus 70 degrees Celsius. Long-term storage of aerobes and anaerobes can be accomplished by freezing at minus 70 degrees Celsius. Frozen non-fastidious organisms should be thawed, re-isolated and refrozen every 5 years. Fastidious organisms should be thawed, re-isolated and refrozen every 3 years. Acid fast bacilli may also be frozen at minus 70 degrees Celsius in 7H9 broth with glycerol. Viruses may be stored indefinitely at minus 70 degrees Celsius in a solution containing a cryoprotectant such as 10% dimethyl sulfoxide, that is DMSO, or fetal bovine serum. Next one is cryopreservation. So freezing in liquid nitrogen at minus 196 degrees Celsius or in the gas phase above the liquid nitrogen at minus 150 degrees Celsius helps the survival of pure cultures for long storage times. In this method, the microorganisms of culture are rapidly frozen in liquid nitrogen at minus 196 degrees Celsius in the presence of stabilizing agents such as glycerol or DMSO, that is dimethyl sulfoxide, that prevent cell damage due to the formation of ice crystals and promote cell survival. This liquid nitrogen method has been successful with many species that cannot be preserved by lyophilization, and most species can remain viable under these conditions for 10 to 30 years without undergoing a change in their characteristics. However, this method is expensive. Lyophilization, freeze drying. Freeze dryer. Most organisms may be successfully stored after lyophilization. Freeze drying is a process where water and other solvents are removed from a frozen product via sublimation. This process consists of 3 steps. Pre-freezing the product in laboratory freezer to form a frozen structure. Primary drying to remove most water, and secondary drying to remove bound water. Lyophilized or freeze-dried pure cultures are then sealed and stored in the dark at 4 degrees Celsius in refrigerators. Many species of bacteria preserved by this method have remained viable and unchanged in their characteristics for more than 30 years. Advantage of lyophilization. Only minimal storage space is required. Hundreds of lyophilized cultures can be stored in a small area. Small vials can be sent conveniently through the mail to other microbiology laboratories when packed in a special sealed mailing container. Lyophilized cultures can be revived by opening the vials, adding the liquid medium and transferring the rehydrated culture to a suitable growth medium. Recovery of bacteria from lyophilized storage condition. Remove the frozen cultures from the freezer and place them on dry ice or into an alcohol and a dry ice bath. Transfer to a laboratory safety cabinet or a Clean area if a cabinet is not available. Scrap the topmost portion of the culture using a sterile loop. Transfer to a growth medium without contaminating the top or inside of the vial. Reclose the vial before the contents completely thaw and return the vial to the freezer. With careful technique, transfers can be successfully made from the same vial several times. Incubate for 18 to 24 hours at 35 to 37 degrees Celsius. Perform at least one subculture before using the isolate to inoculated test. Next one is paraffin method. Preservation of organisms by overlaying culture medium with mineral oil is a simple and economical method of maintaining pure cultures of bacteria and fungi. For example, PDA slants, that is potato dextrose agar slants, may be overlaid with sterile mineral oil and stored at room temperature for the longer term storage of fungi. In this method, sterile liquid paraffin is poured over the slant of the culture and stored upright at room temperature. The layer of paraffin ensures anaerobic conditions and prevents dehydration of the medium. This condition helps microorganisms or pure culture to remain dormant. Therefore, the culture can be preserved from months to years. Prepare tubes of hot infusion agar with the short slant for fastidious organism and fresh native or heated blood. Sterile mineral oil in hot air. Grow a pure culture on the agar slant. When good growth is seen, add sterile mineral oil to about 1 centimeter above the tip of the slant. Subculture when needed by scraping growth from under the oil. Store at room temperature. Transfer after 6 to 12 months. Thank you.